finally came up with the second part. The first part was an introduction to econometrics, and I have already explained that econometrics is what is an amalgamation of economics, mathematical statistics and mathematics, because it is not just economics but the verification of the economic theory in addition to the statistics and mathematics, right? So now very much important is that one needs to understand what do we mean by the term regression, because in economics everything is about the econometrics data and everything is there. So for that what we required is that the regression meaning we need to know. Like the term regression was introduced by whom? By Francis Galton. And one more thing, if you are applying for any examination, there are certain MCQs, so you need to remember all these points. Galton found that although there was a tendency for tall parent to have tall children and for short parent to have short children, the average height of children went to the average height. So why this? This Galton's law of universal regression was confirmed by his friend Carl Pearson, who collected more than 1,000 records. He found that the average height of son of a group of tall father was less than their father's height, and the average height of son of a group of short father was greater than their father's height. So this modern interpretation of regression, like regression analysis, is concerned with the study of dependence of one variable, the dependent variable, on one or more other variable. Like he has used scatter diagram to show this. And this diagram, you can see it gives a distribution of population of heights of boys measured at fixed dates. It's an average one it shows. These are the examples which are being provided, which I am not discussing. So the main thing is that some terminologies we need to understand. The regression is one of the important part for understanding econometrics, like that random or stochastic. This term is very important. In statistical relationship among variables, we essentially deal with random or stochastic variable, that is variables are a probability distribution. In functional deterministic dependency, on the other hand, we also deal with variable. The dependence of crop yield on temperature, rainfall, sunshine, fertilizer, for example, is statistical in nature, in the sense that the explanatory variable although certainly important, will not enable the agronomist to predict crop yield. So in deterministic phenomena, on the other hand, we deal with relationship of the type, say, exhibited by Newton's law of gravity. Every particle in the universe attracts every other particle. Symbolically, F equals to K, where F is a force, M1, M2 are the masses. So like this. Now the most important part is that one needs to understand the difference between regression and causation differently. Okay, regression analysis deal with the dependence of one variable on other variable. It does not necessarily imply causation. In the words of Kendall and Stewart, a statistical relationship, however strong and however suggestive, can never establish causal connection. In the crop yield example cited previously, there is no statistical reason to assume that rainfall does not depend on crop yield. So the fact that we treat crop yield as dependent on rainfall is due to non-statistical consideration. So regression versus correlation, closely related to, but conceptually this is very much different from regression analysis. But the primary objective is to measure the strength or degree, which we will learn. Like it may be find interesting in the correlation between smoking and lung cancer between in regression analysis we are not primarily interested in such a measure, but in correlation it is a degree. They have some fundamental difference, like there is an asymmetry in the way the dependent and explanatory variable are treated in regression analysis, and the dependent variable is assumed to be statistical, random or stochastic, that is to have a probability distribution. The explanatory variable, on the other hand, are assumed to have fixed value. Now these are the dependent variable which can be called, it can come like the dependent variable and the explanatory variable. Like if you see the equation y equal to x1 plus beta 1 x2 plus error term. So here y is the dependent variable, or we can say it as explained variable, predictant, regressant, response, endogenous outcome or controlled variable. And the explanatory variable or beta 2 is the independent, predictor, regressor, stimulus, exogenous, covariate, control variable. So we can call it by any name. Here the x1 is the intercept and beta 1 is the slope. Okay, and mu1 is the error term, because there are certain things that it will also depend on. So that is very much important. Now there are many things, 2 variable regression, multiple regression, more than one, right? Not only one factor, but there are many factors. Equation can go like y equal to x1 plus x2 beta 2 plus x3 beta 3, like this. Okay, so the term random is a synonym for the term stochastic. This we need to remember. Like we have noted earlier, random, this terminologies we need to know, as I mentioned. Okay, now most important is that there are things called data, the type of data. There can be many types of data. So the types of data, which is very understand, time series data, by the name it says that it can be weekly, daily, monthly. The examples are also being provided: quarterly, quinennially, or decennially. That is every 10 years. So it can be like this. Time series data are used heavily in econometric study, as we will show in chapter. Although it is too early to introduce a precise technical meaning, loosely speaking, a time series is stationary if its mean and variance do not vary. Cross-section data, on the other hand, like the data one or more variable which are collected at the same point in time, that is like the conducted by the census bureau every 10 years. So that is the cross section data. Now the third one is a pool data. It is like combination of both time series and cross section. Okay, we have 50 cross section, like that. For each state we have 2. Now panel data is like pooled only, but is a special type. Okay, like it will take out or carry out a census of housing at periodic interval, and at each periodic the same household will be interacted with the time and cross-sectional data. So this is very important. So this is the thing, this is an example which we will discuss in the next session. So this is the second introductory session for the econometrics class. Please do like and subscribe to the channel for more such videos. Thank you.